let's talk about how to solve exponential equations using logs. So, what's an exponential equation? An exponential equation is anything where the variable is in the exponent. So, for example, if I have 2 to the x equals 8, my variable is in the exponent. How do we solve this? Well, we used to use a common base. So, 2 to the x is equal to 2 to the third. Once I have a common base, I can drop them out and only focus on my exponents, set them equal to each other. However, what happens when you can't find a common base? So let's say I have 2 to the x equals 9. I don't know how to find a common base because there isn't one. I can't write 9 as a power of 2. So what we do is we convert it to a log, and then we use our calculator. So if I have a base of 2, I'm going to keep my base. So log base 2, and then these two pieces switch places. Log base 2 of 9 is equal to x. This is going to go into my calculator using alpha window. So alpha window, choice 5 says log base, and now I can put in base 2 of 9. And I get 3.169 and so on. So I want to talk about this answer two ways. If it says exact value means you can't round. So we would leave it in terms of logs. So it would say x equals log base 2 of 9. Otherwise, they would have to give you rounding instructions. So let's say nearest tenth. That means I can go to this step here and round appropriately. So nearest tenth, let's just do a little refresher, is 1 decimal place. So I want to keep that decimal place, so I go 1 past it. The 6 tells me to round up, so this becomes 3.2. So just keep that in mind as we go through some of these questions. We're going to pay attention to the directions. So example 1. Solve e to the 4x equals 12 algebraically for x rounded to the nearest hundredth. So I'm thinking nearest hundredth, what does that tell me? I'm going to use my calculator to evaluate the log. So my variable's in the exponent. I can't find a common base. I'm going to keep the base and switch. So this is my base. And then these two pieces switch. So log base e of 12 is equal to 4x. Now, remember that log base e is not something that you will usually see. Log base e is really the natural log, which is ln. So I have ln of 12 is equal to 4x. Because I'm allowed to round, I'm going to go right to my calculator. The natural log of 12. Remember, natural log is the button on the left side next to the 4. 2.4849, and so on, it continues, is equal to 4x. I want to solve for x, so I'm going to divide by 4. So divided by 4, x equals 0.62122. They want the nearest hundredth, so 2 decimal places. X is equal to 0.62. Let's take a look at another one. Find x to the nearest tenth. 3 to the power of x plus 1 is equal to 5x. So keep my base, log base 3 of 5, because these are now going to switch places, is equal to x plus 1. So now in my calculator, alpha window 5, log base, log base 3 of 5. So log base 3 of 5, 1.4649. is equal to x plus 1. I'm going to subtract 1 on both sides. So 0.46497, and so on. They want it to the nearest tenth, so x equals 0.5. Let's take a look at another one. This time it says find the exact value of w. So what does exact value tell me? Don't round, which means leave log in the answer. So 5 to the 2w minus 9 equals 40. I'm sorry, plus 9 equals 40. The first thing I need to do is isolate the base. So I need to get that 5 to the 2w by itself. So I'm going to start by subtracting 9 on both sides. So 5 to the 2w is equal to 31. Now that the base is alone, I'm going to keep the base and switch to convert it to log. So here's my base, log base 5. The other two pieces switch spots. Log base 5 of 31 is equal to 2w. This is the step where you would normally go to your calculator, but remember those directions said exact value, so I'm going to leave it. Now I'm going to divide because I still want to get that w by itself. So w is equal to log base 5 of 31 all over 2. And that's our exact value of an answer because I didn't round. Okay, let's look at another one. Solve for x to the nearest hundredth. So once again, nearest hundredth means I'm rounding, which means I'm typing in my calculator. 3 times 2 to the x equals 9. I want to isolate the base, meaning that 2 needs to be by itself. You cannot multiply here. Please be careful. What I need to do is I need to divide on both sides. So 2 to the x equals 3. Now my base is isolated. Keep the base, log base 2 of 3 equals x. Go to my calculator, alpha window 5, log base 2 of 3, 1.5849 is equal to x. They want it to the nearest hundredth, so this is 2 places. So 2 places, 4 tells me to stay. X equals 1.58. Let's take a look at one last example. Solve for x in terms of logarithms. So in terms of logarithms is the same thing as exact value. Which means I'm not using my calculator because I'm not rounding. So logs need to be in my answer. I need to isolate that base. So I'm going to divide both sides by 2. So e to the 3x equals 6. Now keep the base and switch to turn it into a log. So remember, with e, your base is really, with e as your base, your log is really the natural log. So the natural log of 6 is equal to 3x. Normally I'd put the left side in my calculator, but I want the exact value or in terms of log, so I'm not going to my calculator. I still need to solve for x, so I need to divide both sides by 3. So x is equal to the natural log of 6 all over 3. Be careful not to divide that 6 and 3 because that 6 is attached to the natural log. You cannot do 6 divided by 3. If I were to do this by rounding, I would do the natural log of 6 first and then divide by 3. So this is how you solve exponential equations using logs when you can't find a common base.